Okay, so in this video we're going to look at the inverse cosine and calculators. Right. Now, similar to our previous video with the sine, here we have our inverse cosine. Right. Domain, very similar to the sine. The major difference here is our range. Our range gives us an angle between 0 and pi, whereas sine gave us an angle between negative pi over 2 and pi over 2. Right. Reasons for that gone over in a previous module, right? So here we're going to apply this to solve problems. For example, let's start with this example here, where we are asked to find all angles in the interval 0 and 2 pi, such that cosine theta is equal to 0.02. All right. Okay, now one thing here, we're gonna start off, all right, cosine is positive. That means we're looking for angles that lie in quadrants 1 and in quadrants 4, right? So we have theta 1 to be here, and then our other angle is theta 2, which is going to be down there. Theta 2. Okay, so we'll start off again using our understanding of inverse functions. So if cosine of theta is equal to 0.02, this is true, again, if and only if, right? Arc cosine of 0.02 is equal to theta, excuse me. That is the definition of inverse functions in general, right? And here we're dealing with an inverse cosine. So I'll take out my calculator. Again, this is our angles, not in our unit circle. So arc cosine here, and again, right, we hit second, and above the cosine, that's cosine to the -1, right? Not an exponent. That's just an alternate formulation for our inverse functions. All right, so type in 0.02, and we get 1.55. Okay, so that means that theta is equal to 1.55. All right. Okay, so our range here, that theta is in quadrant 1. Okay, so that means here (1.55). This also happens to be our theta 1, so we get theta 1 right away. All right, and it's also our reference angle. All right, it's the acute angle between the x-axis and the terminal side of our angle. All right, now I point that out because that's going to help us find theta 2. All right, theta 2 is in quadrant 4. That would be theta 2. All right. Okay, well, in order to find that, I need to realize that this is theta r, or 1.55. Right? So theta 2 is going to be 2 pi, but that would be too much, right? That goes all the way over here. We cut out theta r, or subtract minus 1.55. Okay, and then just a quick calculation here. So we get 2 pi minus 1.55. We get 4.73. So theta 2 is 4.73. And from our initial calculation, theta 1 is equal to 1.55. All right, and right away, all right, with a little bit of work, we're able to get both of these angles. Okay, again, right, remember, calculator, very fast, right, to do calculations, not very smart, right? There's no way that it can give you these two values. It is up to you to interpret with our knowledge that we've gained so far in this course. Okay, let's look at one where the value of cosine theta is negative. Okay. Okay, so here, for this example, let's say I want to find all angles in the interval such that cosine of theta is equal to negative 0.58. Okay, all right. Okay, so we're looking for two angles here, right? Because I know the cosine is negative in quadrants 2 and quadrants 3. Right, so theta 1 would be this angle here, and then theta 2 would be this angle here. Okay, so those are the two angles that we're looking for. Okay, so we'll start off like we did in the previous ones, right, where we use our knowledge of inverse functions. So we have cosine of theta is equal to negative 5800ths. So this is true if and only if arc cosine of 0.58 is equal to theta. All right. Okay, so we apply, or excuse me, we take our calculator out, and let's use our inverse cosine, and inverse cosine, ooh, forgot a negative there, of negative 0.58. All right. Hit enter and we get a value of 2.19. So theta 2.19. Okay, so let me plot this to see what we just found here. All right, so here cosine is negative. The cosine inverse gives me an angle between 0 and pi. So what we just found was actually theta 1. That is 2.19. All right. Now, how can we find theta 2? Right, theta 2 is somewhere right here, right? This is going to be theta 2. Okay. Well, I need to find what theta r is, right? Well, this value here is our reference angle. Well, this value here is also our reference angle, right? That's how these reference angles work here. Okay, well, theta r, I need a little bit of work here. Right? 1/2 revolution is pi, but that's too far by this many radians, 2.19. So theta r is going to be pi minus 2.19. Right? It gives me a value of 0.95. 95 hundredths. Okay, so now I am able to find theta 2. Right? Theta 2 is pi plus that theta r. Right? So here, theta 2 is going to be pi plus 95 hundredths. So calculating that, we get 4.09. And then from our initial calculations, we get 2.19. And now we have both angles that satisfy cosine theta equals to negative 0.58. All right, thank you.